In the last lecture, we have completed the IBGP things. We have seen the route reflector and all these things, correct?
Right.
Now what we will study, we'll start with eBGP. eBGP, external BGP. External BGP neighborship. Now how external BGP neighborship is done? Okay, so external BGP means we will be running different autonomous system. Okay, so what I will do, okay, this is the document for BGP that I have made personally. Database table, split horizon, active state, source, loopback, authentication we have seen, then peer groups, then full mesh neighborship, then we have seen route reflector as well. Okay, so here the eBGP thing is not there over here. Okay, no issues. So after route reflector, we will see the eBGP neighborship. Now, how to configure eBGP neighborship? What I will do, I'll take only R1, R2, and R3. What I will do, R1 and R2 like this, they will be in autonomous system, suppose 500. Okay, and my this loopback and this R3 will be in AS 600. Okay, this is my plan. This is what my plan is. Okay, I'll open that image that we were using previously also. What I said, these all will be in AS 500 and these will be in 600. Got it? So we are having two, we are having what? Two autonomous system. Okay, so how to configure it now? What is the configuration part that we need to do? So I'll just make this router down because we don't need this router. R1, R2, and R3. Show IP protocol, there is no protocol running. Okay, so we will be running BGP over here. So how to configure BGP? The basic router BGP 500. Okay, I will say neighbor. My neighbor is, I'll form the neighborship with physical interface. I'll say 1.1.1.2. Remote AS is 500 because this will be in 500 as per my plan. So I'll open the plan over here like this. Then I'll advertise my LAN network 10 dot network. No auto summary, no synchronization. End. router BGP 500, neighbor 1.1.1.1, remote AS is 500. And I have one more neighbor on R2 that is 2.2.2.2, but it is in which AS? It is which AS? It is in 600. It is in 600. Okay. So 2.2.2.2 with remote AS 600. This remote AS thing will give me that it is an iBGP neighbor or it is an eBGP neighbor. Okay, got it? Now network 20 dot network, no auto summary, no synchronization. R3 router BGP 600 because R3 is totally in 600. Okay, my neighbor is 2.2.2.1 and it is in remote AS 500. Network 30 dot network, no auto summary, no synchronization, end. Let me go on R2 and see show IP BGP summary. You can see I am having the neighborship. Now the neighborship came up over here also. So I am having two neighbors over here 1.1.1.1 and 2.2.2.2. Correct? I'll see BGP table. Show IP BGP. This is my BGP table. You can see I'm getting 10 dot network, 20 dot network, as well as I'm getting 30 dot network. Okay, got it? If I go on R2, sorry, R1, if I see show IP BGP, I'm getting 10 dot, 20 dot, and 30 dot network. Now here you can see, if you see the 30 dot network, you can see the next hop over here. What is the next hop? The next hop on R1, it is showing as 2.2.2.2. The next hop, it is showing as 2.2.2.2, correct? And if I see the BGP routing table, show IP BGP route, sorry, show IP route BGP, I will not see the 30 dot network. See, 30 dot network is not present in the routing table. Why? Because the next hop that it is showing over here, 2.2.2.2, okay, due to this next hop, because this next hop is unreachable. You are not able to reach this 2.2.2.2. You are not able to reach this 2.2.2.2. That is why you are not able to see the 30 dot network in the routing table of R1. Okay, so this is the default next hop behavior of BGP, you can say. This is what default next hop behavior of BGP. This is default next hop behavior of BGP. Okay, now to fix this issue, either you can advertise the WAN interfaces. Okay, what you can do, you can advertise the WAN interfaces. Like I haven't advertised the WAN interface, show run pipe section BGP. You remember I haven't advertised the WAN interfaces. I only advertise my network. With the network command, I only give my 10 dot network, my LAN interface. The second solution is change the next hop address to the next router address. Now, what is the next hop address when we see the normal routing? When we use normal routing, So when we use normal routing, suppose I am having one router over here, one router over here, one router over here, one router over here. Now, whenever we use normal routing, what we do, our next hop is next router. Correct? Suppose these are in one autonomous system. This is one in one autonomous system. Okay. All are in 10 dot network. Some of the 10 dot network they are using. Any 10 dot network, you can say they are using any 10 dot network. Now, the thing over here is, if we use normal routing, in normal routing, always my next hop means next router. Next hop means in normal routing, next router. Correct? To reach the next hop, I need to go to next router. But when we use BGP or eBGP to eBGP neighbor, okay, it changes the next hop. When IBGP neighbor, the next hop remains the same, unchanged. Okay, so when we use BGP, next hop is equal to next autonomous system. Next hop is what? Next autonomous system. So here if you see, what is the next hop? This autonomous system's last IP address is this. So for every router, if suppose I was having one more router over here connected to this router, here also, if suppose I would have here I would have 50 dot network. Okay, so on this router also, if I see, to reach the 30 dot network, my next stop would be this only, because BGP's default next stop behavior says that BGP is an AS by AS routing protocol. What it is? It is an AS by AS routing protocol, not router by router routing protocol. So in BGP, the next hop does not mean the next router. It means the IP address to reach the next autonomous system. Understood? See here, my this AS500 is, this is the boundary of AS500. From here, how I can reach the next stop? This is how I can reach the next autonomous system. So this is the next stop for this autonomous system 500. So inside this autonomous system 500, all the routers will be having the same next hop by default for to reach this 30 dot network. Understood? Getting me?
Yes.
So how you can do the things now? There are two solutions. As I told you, the first one is either advertise the WAN interfaces or change the next hop address to next router. What is the BGP's next hop address? Again, I'm telling you, when eBGP will send an update uh, to eBGP neighbor, to another eBGP neighbor, it changes the next hop. When iBGP neighbor sends an update to another iBGP neighbor, see, when these both are now IBGP neighbor, because they are in same autonomous system. When IBGP neighbor will send an update to another IBGP neighbor, okay, the next hop remains the same. Whatever the next hop over here it was, it will be shared at same. If this router will share with the another IBGP neighbor, it will share the same next hop 2.2.2.2. Understood?
Why don't we advertise the WAN
We can
network?
do anything. As I told you, there are two solutions. Either we can advertise the WAN interfaces. So we have already seen how to advertise the WAN interfaces. So why should we see it again? So I'll just
Okay.
let you know that how to do the next hop addresses. There are two solutions. Either advertise the WAN interfaces or change the next hop address to the next router address. Okay. Now to
So
change
advertise
this,
the WAN. Sorry. Advertise the WAN interface on R2 only, right? Not required on R1.
Why it will be required on R1 also?
Yeah, if from R1 also is there. But
Yes.
for next hop address only need to be defined on R2, right? Or also on R1.
Next hop will be
Just one minute.
defined on the border router. Next
Border
hop
also.
will be defined on the border router only. The router that is connected, that is direct neighbor with the another autonomous system. Understood? Okay, to change this behavior manually, what you need to do, you need to tell the change, you need to change the next hop address. Okay, done on the border router, pointing to internal BGP neighbors. Okay, so how you can do on R2. Now R2 is my border router over here. R2 is my border router over here. So what I will do, I'll go on R2 and I'll say router BGP 500. I'll say neighbor 1.1.1.1. For this neighbor, the next hop is self. Next hop is my interface. Next hop will be my interface. Got it? What I'm saying over here, for my neighbor 1.1.1.1, next hop will be self, means my interface. Next hop will be my interface. That's it. If I go on R1 and if I check show IP route BGP, see I got the 30 dot network. Show IP BGP. Next hop got changed 1.1.1.2. Correct? Understood? This is BGP's next hop behavior.
Have you defined next hop on R2? I haven't seen.
Why I will, yeah, I have defined, I have said that. See what I've said for my neighbor,
But
for my neighbor 1.1.1.1. What I said on border router. For my neighbor 1.1.1.1, the next hop will be what? The next hop will be my router. I will be the next hop. Next hop will be self.
what about for 2.2.2?
Dot two, this dot 2.2.2.2 is the next hop for this.
So we haven't defined, right, for 2.2.2, right?
No, why we need 2.2.2.2?
See,
I don't
see
need the
if
next hop.
R1,
See, you're getting confused. On R1, previously, what was the scenario? On R1, I was not getting the 30 dot network, correct? I was not
yes,
getting the 30 dot network. Okay.
yeah,
And what it was showing on R1, to reach the 30 dot network, the next stop is 2.2.2.2.
yeah.
Correct. But when I was seeing the routing table, I was not getting this. Why? Because this next stop was not reachable. I am not directly connected to this next stop. This is not reachable. Why it is showing me? Because BGP is AS to AS uh, routing protocol, not router to router routing protocol. What happens in BGP? This is my autonomous 500. Here my boundary of autonomous 500 and this is my autonomous 600. Okay. Now, what BGP says? See, I'll open this. Next stop behavior must be there over here. I haven't written the thing for next stop behavior. So what BGP says that when anyone is advertising anything, any network, and it is coming from some eBGP neighbor, then it will, what it will do, it will change the next hop. So what R2 said that if R2 got an advertisement of 30.network and it got the next hop address is this. Understood till here? Now, when R2 gets the eBGP neighbors network, when R2 will advertise this network to iBGP neighbor, these are iBGP neighbor within an autonomous system. R1 is iBGP neighbor. Agreed?
Yes.
R1 is iBGP neighbor. Whenever R2 will advertise it to R1 or any other router inside the iBGP neighborship, what R2 will say, R2 will not change the next hop address. When he will advertise to iBGP neighbors, he will not change. He will advertise, if you want to reach 30.network, go to 2.2.2.2 is your next hop address. Understood? But from R1, you cannot reach 2.2.2.2 because you are not having any route to reach 2.2.2.2 network. Understood? That is why what we said on the border router, what we said that for this neighbor, the next hop is, I am the next hop address. My interface is next hop address. Got it?
Okay.
Still you have doubt, you can ask me. There is no issue. I'll explain one more time, two more times.
No, I got it. Thank you.
Okay. Now, this is eBGP neighborship. This is how eBGP neighborship is done. So what we have seen eBGP neighborship with next hop address, how to change the next hop, correct? Now you can use eBGP with loopbacks also. Okay. Now why we need eBGP with loopbacks, or why we need, suppose we are having, suppose the scenario is, we are having one router over here, one router over here, and both the routers are in different autonomous systems. They are connected with a link. So what happens if this link goes down? There is a single point failure. Now neighbor uses any one link to form the neighbors. So if we connect two links also, suppose we connected two links, eBGP redundancy. If my first link goes down, the second link is there. So if the interface goes down, if the first link goes down, because neighbor uses only one link to form the neighborship, we will give only one neighbor command, okay, for one neighbor. Now if the interface goes down, the neighbor goes down, okay, neighbor is not reachable. This is single point failure. If we connect multiple links also, then there is a single point failure. What we can do, we can use something known as, for redundancy, we can use loopback in eBGP. In eBGP also, we can use loopback. Now, loopbacks will be reachable. Suppose we are having loopbacks over here also and over here also. Now, if my one link goes down, loopbacks are still reachable from the second link. Okay, loopbacks are reachable via path 1. Okay, eBGP path 1. If path 1 will fail, it will use the second link automatically based on the routing, correct? Because what is the concept of loopback? If you want to configure loopback addresses, what we do?
we need to have IGP.
IGP protocol. We need to have
Yes.
IGP protocol.
And
Correct?
also update loopback source the command.
Yes. So suppose this is my company's router and this is my ISP router. Okay, this is my ISP's router and this is my company's router. So what we do, we usually have one link, or for redundancy, we can have two links. So what we'll do, I'll make this link as primary and this secondary. I can use some static routes. I can use some static routes, correct? Floating static routes, you can say, or you can use some dynamic routing protocol also. Got it? But in this scenario, if I take this scenario, customer end and ISP end, we'll be using some static route over here and default route or something. So in this scenario, we can use some static route over here, and here we will give some floating static values. We'll increase the AD value on the second route. Understood? So with the help of loopback, what we can do, we will not have a single point failure in eBGP neighborship. There will be redundancy. eBGP neighbors using loopback addresses. Got it? Any questions? So this is the topology. Okay, this is a small topology. So this router, okay, so this will be in, suppose, autonomous system 500, and this will be in AS 600. Okay, this is my plan. I have two links between the routers. So let us configure eBGP peering between R1 and R2. Okay, whatever we have seen as per the diagram. And I will make sure that the eBGP neighbor relationship, it should not get affected. It should not be affected by the physical status of the link. Okay, so if the one of the physical link goes down, then also it should not affect it. Okay, and I'll configure some static routing to provide reachability between loopback interfaces on R1 and R2. So I'll see whatever things are configured, pre-configured things are there. Show IP protocol, show IP interface brief. IP addresses are pre-configured. I have loopback addresses as well configured. On R1, I have 11 dot. On R2, I'll be having 12 dot. Okay, show IP route. I only have connected routes. Okay, so what I will do now, I'll configure router BGP 500. I'll say neighbor 1.1.1.2, or I want it for loopback. So 12.0.0.1. Remote AS is 600. Neighbor 12.0.0.2 Now here you can use peer group also, because we are having for neighbor, we are having the same commands. Neighbor, for same neighbor, we are having multiple commands. Update source loopback 0. Neighbor. Now here you have to give one more command, neighbor 12.0.0.1, and you have to say ebgp multi-hop. Now ebgp multi-hop, this command increases the default of one hop for ebgp peers. Okay, default hop, one hop for ebgp peers. Now it allows router to the ebgp loopback addresses. Okay, routes to the ebgp loopback addresses. Now you can say which will have a hop count greater than 1. So ebgp multi-hop tells to either that the 12.0.0.1 is not directly connected and it is a multi-hop away. What I'm saying over here, on this router, I'm saying the neighbor 12.0.0.1 is not directly connected. It is multi-hop because this is a logical interface. It is not a physical interface. So when I am configuring eBGP neighborship with a loopback, I have to give this command because my loopback is not directly connected. Understood? eBGP multi-hop. Then I'll advertise network 10.network, no auto summary, no synchronization. On R2, router BGP 600, neighbor 11.0.0.1, remote ASS 500, neighbor 11.0.0.1, update sources loopback 0, neighbor 11.0.0.1 is, here we have what? eBGP multi-hop, and network 20.network. No auto summary, no synchronization. Okay. Now, if I go on R1 and if I check show IP BGP summary, I'm having one neighbor, but the state is active. The state is active. If I try to ping the neighbor, I'm not able to ping. Why? Why I'm not able to ping test? Because
IGP missing.
yes, the routing issue. Routing issue. There is a routing issue. If I see show IP route, I'll be not having the routes for 12.network in my routing table. So my R1 do not have any route for 12.network in to which it is peering. So to what we have to do to provide reachability, either we can use any dynamic routing protocol or we can use static routing. Okay, so in general we prefer to use static routing between different autonomous system, but you can also use dynamic routing also. So what I'll do, I'll use my static routing IP route to reach the 12.network 12.0.0.0 0.255 to 55 to 55, go to 1.1.1.2. Okay, this is my prime. Sorry, I have given wildcard bits. Subnet mask I have to give 1.1.1.2. This is my primary link, and for secondary link I will give 2.2.2 and I will give the AD value as 10. On R2 also I'll do the same, IP route to reach the 11.0.0.0 network to 55 to 55 to 55.0, go to 1.1.1.1. This is my primary link, 2.2.2.1. This is my secondary link. So what I will do, I will give the floating static routes. From R1, if I try to ping, now I am able to reach the loopback address. If I see show IP BGP summary, my neighborship is up now. My neighborship is up. Understood? If I see show IP BGP.
Qayyum, just one question, sorry. Under the state prefix received, you are seeing 1. In my case, I was seeing 0. So does it mean I have the neighborship?
You haven't advertised any network. Have you advertised any LAN network? See, whatever you advertise over here, show run 5 section BGP, whatever you advertise over here with the network command, you will get the things over here. How many networks?
So, okay, 0 means maybe I haven't advertised, right?
Yes. So I have only
I will check
advertised,
it
I am
out.
only getting one network prefix from the neighbor. Understood? If I advertise
Okay.
the loopback also, then I will be getting the loopback also. Okay. If I
And one more thing, yeah, in your case, before you defined a static route, it was active, right? The state. In my case, I was saying idle. So is it different or same?
see, active and idle both are different but somewhat same. After idle, it will come to active. Okay. After idle, it will come to active. Okay. So both are same, both will not form neighborship. Not same, you can say, both are not exactly same, but when you are having both these, they will not form neighborship.
Okay, got it.
Okay. Any other questions?
No.
So now I am having the neighborship over here. See, so now you got all the things, the prefixes, you got the prefixes or something. See, whenever you are getting active or idle or something else, connect or open send or open confirm, then you need to know that there is some issue. Idle state is something that uh, open sent message is given and then it went into active, then again the active went into idle, then again it is coming to connect, open sent, and then again it is going to active. It is roaming, it is going in loop. Okay.
Yeah, I got it. Thanks.
So this is my eBGP neighborship with redundancy. Understood?
Here we are not defining anything like next hop because
No, here we are not defining because we are not having any other router. If I would have one more router connected over here, okay, and this was in AS 500, then I have to define
inside
on for this router, I have to
500.
define that for my neighbor, for this router, the next hop is
Yeah.
this interface.
Okay, on the BGP border router, we define the next hop for all the internal BGP router, right?
Yes, for all my neighbor.
Internal IGP neighbors,
Yes,
right?
in IBGP neighbor.
Yeah, yeah.
Understood?
Can you just show history once? I will just take a note for the command on R1 only. Yeah. Done.
Okay. Now I was using a command no synchronization. Someone asked me in the last lecture or previous lecture that why you give no synchronization. Synchronization, why I give no synchronization? Synchronization rule says if I enable synchronization, it will say do not use or advertise to an external neighbor a route learned by IBGP until a matching route has been learned. What it says, do not use or advertise. Suppose if I give you an example, suppose I am having an autonomous system over here. This is my one autonomous system. This is my one autonomous system. And here inside this autonomous system, I'm having some routers. Okay, here I am running BGP. I can say here I am running BGP. BGP. Okay. Here I am running, suppose in this router BGP also and OSPF also. BGP and OSPF. Now here I am having another autonomous systems also over here. These are my other autonomous system and they are also having some routers inside them. Now whenever I enable synchronization rule, suppose I am having some 20 dot network on this router. Some 20 dot network is there. And here some 10 dot network is there in the LAN. Now whenever I am advertising to BGP neighbors, okay, whenever I am advertising it to any BGP, okay, internal BGP, okay, then there is no such issue. But whenever I am, if synchronization is enabled, what I say no synchronization means I disable the synchronization. If suppose by default the synchronization is enabled, so if I don't disable the synchronization, it will never pass the information. It will not advertise it in another autonomous system. If we are running OSPF, suppose if we are running OSPF, then it will not advertise until this 20 dot network match is found over there. Until the 20 dot network match is found over there. What does the synchronization rule says? Synchronization rule says it ensures consistency of information throughout the autonomous system. It's safe to have it off only if all routers in the transit path in the autonomous system are running full mesh IBGP. Off is by default in Cisco iOS software. Got it? So whatever I was doing, the no synchronization command, the command disables BGP synchronization so that a router will advertise routes in BGP without learning them in an IGP. So if I don't learn any route, see here I have learned this route in IGP also. Now if I am advertising it to this router and this is he is advertising it to eBGP neighbor, it will be allowed. But if I am not advertising it in any IGP protocol and the synchronization rule is enabled, then it will never pass this information to any eBGP neighbor, external BGP. Okay, synchronization rule means if I give the synchronization command, it enables BGP synchronization. What it will do? It will the router will not advertise routes in BGP until it learns them in an IGP protocol. Got it? Let us see practically. how it works. So I'll open our that topology only. I'll be using R1, R2, and R3. I'll change the plan somewhat. What I'll do, these will be in autonomous 600. Okay, take all of this 600, and these will be in autonomous 500. This will be my plan. I'll configure BGP peering as whatever we have seen. Then I'll disable the synchronization rule. First, I'll disable the synchronization rule and we'll see the output. Then we will enable the synchronization rule and we'll see the output. We'll see the difference in both the commands. So quickly configure router BGP 500 neighbor 1.1.1.2 remote AS is 600 network 10 dot network. Now see what I'm doing over here. I'm advertising the 1 dot network as well. No auto summary, no synchronization. Router BGP 600 neighbor 1.1.1.1 remote AS is 500. Then neighbor 2.2.2.2 remote AS is 600. No auto summary, no synchronization. Network 20 dot network, 2 dot network, and 1 dot network. Router BGP 600 neighbor 2.2.2.1 remote AS is 600. No auto summary, no synchronization. Network 30 dot network and 2 dot network. Okay. And now what I need to do, if I see show IP BGP summary, show IP BGP summary on R2. See, I'm learning. I have advertised two networks, the WAN and the LAN. So I'm learning two networks. My neighborship is up. Okay, my neighborship is up. If I see show IP BGP, I'm getting all the networks. Okay, I'm getting all the networks. If I go on R3, show IP BGP, I'm getting all the networks to reach the 10 dot network. What is the next stop? 1.1.1.1. Okay. If I see show IP route BGP, I can see the 10 dot network in my routing table. Okay, so I can reach the 10 dot network. Now my task is I will enable synchronization on all the three routers for verification. What happens? Now see the output, whatever I have shown you on R2 and R3, and see the difference now. If I go on all the router BGP 500, and if I say synchronization, router BGP 600, and if I say synchronization, router BGP 600 and synchronization. Show IP BGP. To reach the 30 dot network, 2.2.2.2 is the loopback to the 30 dot network. If I see for only 30 dot network, show IP BGP 30 dot network. Origin from IGP, origin from IGP, not synchronized. You can see not synchronized. Okay, if I see show IP route BGP, why I'm getting the 30 dot network? Clear IP BGP
Clear the BGP process.
star soft. Why I'm getting the 30 dot network here? If I enable the 30 dot network should not be there over here because it is not synchronized. It will be not synchronized with the R2. Let me go on R1, show IP route BGP. Here also I'm getting the 30 dot network. What is the issue?
Can you check the running config BGP configuration? Synchronization is properly done.
Synchronization is enabled on R2. It is enabled on R3 also.
It must be advertised in some IGP also.
I have not done any IGP protocol. I have not given any IGP protocol. IP protocol. We are only running BGP.
Just check on R1 also. You checked, right?
It should not happen. Clear IP BGP star.
What is the concept behind it? You said we should not be having 30
30
network, right? On
I
R1 and R2.
will not have the 30 dot network unless I use any of the IGP protocol, unless I advertise 30 dot network in any IGP protocol. clear IP BGP star. This is hard way. You should not use this way of hard reset. This is hard reset, you can say. Clear IP BGP star is hard reset. You should not use this way in the production network because you have more sessions running. It will take some time. See now, when I hard resetted the neighborship, I'm not getting the 30 dot network over here. If I go on R1 also, if I check show IP route BGP, wait for some time. See, R3 advertises the 30 dot network to R2, but R2 will not use or advertise this network. Why? Because synchronization is enabled. Synchronization rule is enabled, and as per the rule, the same matching route has to be learned from IGP inside the autonomous system. If I am getting the same route in IGP as well, then I'll be accepting it. I'm getting the route from BGP and IGP both, I will accept it. If I'm only getting from BGP and the synchronization rule is enabled, then I'll not accept. I'll I'll not use it, neither I will advertise to another router. See, understood? Getting me, guys?
Sorry, why it's not taking the 30 route, advertising 30 route, 30
It is
network?
not taking because when I enable synchronization rule, okay, synchronization says that if the matching route has to be learned, if there is a matching route learned from any of the IGP protocol, then only
What do you
I
mean
will.
by matching route?
Matching route means if 30 dot network, if I advertise this 30 dot network in IGP, and if R3 advertise this 30 dot network to R2 in IGP and also in BGP, okay, when the synchronization rule is enabled, if it will advertise in IGP and BGP, both the protocol, then and
That's
only then
that I
R2,
got. Yeah.
then and only then.
Yeah.
See, it has to advertise in BGP also, and it has to advertise it in any of the IGP, suppose OSPF. If it is advertising in both of the routing protocol, then only R2 will accept that route and it will pass the information. It will use and it will advertise. But if it is only using BGP, this 30 dot network is not advertised in any IGP protocol, then the BGP routes, when the synchronization is enabled, R2 will not take this route. It will neither use or neither it will advertise. Understood?
It will not accept any LAN IP, right? Any LAN network
Any
IP
network,
or WAN
any
is there,
network.
right?
WAN is
But
there.
WAN
WAN will be
network is there.
directly connected. WAN will be directly connected,
Okay.
brother.
So any network or interface which is not directly connected will not be
Yes.
advertised
Yes.
if synchronization is enabled.
Yes. If you don't advertise it
Okay.
in BGP.
Okay, got it.
Okay, so we'll stop over here for today. We'll see the solution tomorrow. Like what we can do, we can configure OSPF inside BGP, and we can remove the OSPF, and we can we can disable the synchronization just. Okay, if we are not having IGP protocol inside BGP. Okay.
Qayyum,